Hello and welcome to another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 1, Lesson 11 on translating English to algebra. So what we're going to get some practice with today is really kind of the precursor to those things that are, I bet, your favorite in math, word problems, right? So we want to be able to take phrases that are in English and really translate them into algebraic expressions, okay? We want to look at common things that show up in word problems, common ways of seeing sums and differences and multiplication and division and all of that. So let's launch right into it and get some practice on this translation. All right, so translating addition and subtraction. This should be what we do first since they're the two most basic of operations. Sometimes we'll need to write algebraic expressions that involve various operations like addition and subtraction. We first interpret phrases with addition and subtraction because they're going to be the easiest, although subtraction can be a little bit tricky. So let's take a look at exercise number 1. It is important to be able to recognize addition and subtraction in phrases. First, let us begin with some numerical work and then transition to expressions that contain variables. All right, great. So we're going to start, by writing down expressions that are purely numerical and maybe even giving some values for them. And then we're going to move on to then writing down very similar expressions that involve variables, so algebraic expressions. Let's take a look at letter A. Write a calculation and a result that represents a number that is 5 greater than 3. All right, great. I'd like you to write down an expression that you think represents a number that is 5 greater than 3, and then obviously come up with the answer, which is pretty easy, and I'm sure you can do it in your head, but it's not the point. The point is not the final answer. The point is actually the expression itself. So pause the video now and try to write down a simple expression. Well, there's probably one of two things that you wrote down, right? You either wrote down 5 plus 3, or you wrote down 3 plus 5. Now, due to the commutative property of addition, these two things are equivalent. So I suppose, in a certain sense, you could say that either one of them is correct. And yet, I would claim that strictly speaking, the expression here that really represents 5 more, or 5 greater than 3, is going to be this expression, okay? And not really that expression, right? Because really, this expression says we start with 3 and we add 5 to it. This expression really is 3 more than 5, or 3 greater than 5. Of course, we all know what the answer is to this. It's equal to 8. But that's the expression I hope you have, right? A number that is 5 greater than 3 is 3 plus 5. It is also 5 plus 3, but that actually means something a little bit different. Let's take a look at letter B. Write a calculation and a result that represents a number that is 2 less than 9. Okay, well this is where I hope you were really paying attention on A, because here that order is really going to matter. Pause the video now and write something down. So again, there are likely two different things that you could have written down. The fact that it's less than implies that there's subtraction, and you may have written down 2 minus 9, or you may have written down 9 minus 2. Okay, now unlike addition, subtraction is not commutative. The order that the numbers are written down in makes a huge difference. And in fact, the correct one is again the second one I wrote down. A number that is 2 less than 9, meaning that we're really starting with the number 9, and we want to find something that is 2 less than it, so we need to subtract 2 from the 9, right? This is 9 minus 2. This, is 2, starting with the number 2, and going down 9, right? Here, that would be negative 7. This is the correct one, which is, of course, equal to 7. All right, really key, not 2 minus 9. And the thing that's tricky for kids is that they see the number 2 first. So they say, oh, 2 less than 9. That must be 2 minus 9. Nope. 9 is the number you're starting with, and you're decreasing it or subtracting 2 off. Okay, let's keep going. Again, we're just sticking with these numerical examples. What I'd like you to do now, given what we just did, is pause the video now and do both letter C and letter D. Now, letter C and letter D, right? Letter A was a number greater than, a number less than, right? Letter C and letter D are almost more straightforward. Letter C says, write a calculation and a result that represents the sum of -3 and 8. Well, that is literally -3 plus 8, right? The sum of, right? The sum of. That just implies that we're adding, right? So there's my expression, -3 plus 8, and that's obviously equal to 5. On the other hand, right, letter D, write a calculation and a result that represents the difference of 12 and 20, okay? The difference of 12 and 20. When you see that difference, that's subtraction, right? The word difference means we have a subtraction. And whenever you see it like that, then that implies that it's this number, the first number, minus the second number. So that's going to be 20 minus 12. That's my expression, and its value is 8. Now we want to be able to go from the purely numerical to the algebraic, where we have variables involved. Let's take a look at letter E. If x represents a number, write an expression that represents a number 10 greater than x. Okay, so this is almost identical to what we did in A. Pause the video now and write down an expression for a number that is 10 greater than x. Now again, due to the commutative property of addition, technically you could have 10 plus x or x plus 10, but I really want you to have x plus 10, right? Because this is what you're starting with, right? That's your number, right? I'm starting with this unknown number x, and I want something 10 greater than it, so I have to add 10 to x, x plus 10. Likewise, letter F, if n represents a number, write an expression that represents a number that is 5 less than n, right? So, very similar to before, right? We would have to have n minus 5. All right, and this is critical because if you have 5 minus n, that is a totally different thing, right? 5 minus n, it's almost hard to say this, would be n less than 5. N units, n feet, n seconds less than 5. All right. Now, letter G and letter H are actually fairly simple. Pause the video now and see if you can write down algebraic expressions that model both of those. All right, well, letter G. If y represents a number, write an expression that represents the sum of y and a number 1 greater than y. Well, right, here's y, here's the sum, and what does a number 1 greater than y look like? Well, it looks like y plus 1. So we have y plus, parentheses, y plus 1. Now, technically speaking, again, the parentheses aren't really needed there because addition is associative. But I kind of really want to separate these two things out, right? This is my number y, this is my number 1 greater than y, and I'm adding the two together. If I get rid of the parentheses, then I've just got like, y plus 1, which is the same thing, but, kind of reads a little differently. Letter H, right? If n represents a number, write an expression that represents the difference between a number 1 larger than n and 1 smaller than n. Be careful, right? Right, well, 1 larger than n, right, will be that. 1 smaller than n will be that, and I've got the subtraction. And again, I need to be very, very careful here because, right, if I wrote something like this down, right, just because, I'm just moving fast, here's a number 1 larger than n, here's a number 1 smaller than n, and I subtract, that's actually not correct. Because that subtraction distributes through the parentheses, I'd actually have n plus 1 minus n plus 1. All right? So you got to be careful, right? That would be incorrect. Okay, let's move on. Let's do a little bit with multiplication and division, right? Multiplication and division arise in word problems, and we will need to know how to write an algebraic expression with the information given. Just like before, what we want to do is we want to play around a little bit with numerical expressions, and then we'll get into the ones that involve the variables. Let's take a look at exercise 2. Translate each verbal statement into an expression and evaluate the expression if it is numerical. All right, great. So here we go, letter A. Write an expression for a number that is 5 times greater than 2. 5 times greater than 2. Okay, again, simple enough. 5 times automatically tells us we're doing a product, right? When we see that word, 5 times greater, then that is 5 times 2, right? That is 5 times greater than 2. Letter B, right? If n represents a number, then write an expression for a number that is twice n. Okay, it's the same idea, right? Twice n is just going to be 2n. Simple enough. Okay, so with products, it's pretty easy. You know, you tend to get that times or twice or 3 times, you know. It's a little bit harder maybe when we get fractions involved, but we'll look at a few of those. Letter C, write an expression for the quotient or ratio of 12 and 3. So both of those words, quotient and ratio, imply division, right? And we will always look at division, or we will always represent division in algebra by using a fraction bar. We will never use that classic division sign. You'll hardly ever see that again really in anything, in a math class, in a science class, anything from now on. So when we see the quotient or ratio of 12 and 3, again, it's always implied this number divided by that number. Not necessarily the larger one divided by the smaller one, although that is the case here, but that is the ratio or the quotient of 12 and 3. All right? Likewise, we can see something involving a variable. If x represents a number, write an expression for the ratio of x to 5, right? There's that ratio wording, something to something. The first quantity goes in the numerator, the second quantity goes in the denominator, so the ratio of x to 5 will be x divided by 5. So we've got to have these common phrases like ratio, quotient, product, times, twice, etc. Let's keep going and see if we can maybe do some that are a bit more complicated. All right, the ones that become complicated are when we combine things like multiplication and addition or division and subtraction, because we have to be thinking about our order of operations. That's going to be key when we look at these more complicated ones. So let's take a look at exercise number 3. Translate each of the following statements into an algebraic expression. Let's do letter A. If x represents a number, then write an expression for a number that is 3 more than twice the value of x. 3 more than twice the value of x. All right, let's think about this together. So 3 more than twice the value of x. If I gave you a value of x, like 5, and I said find a number that is 3 more than twice that value, 3 more than twice the value of 5, you'd probably say, well, I need to figure out what twice the value of 5 is. That's 2 times 5, that's 10. Now I need to do something that's 3 more than that. That's 10 plus 3, that's 13. So how do we do in this case? Well, same thing. I need to find a value that is 3 more than twice the value of x. Well, what is twice the value of x? Twice the value of x is 2x, and 3 more than it would be plus 3. 2x plus 3. Great. You just have to be careful, because a lot of students will go, well, I see that number 3 first, so I'm going to do 3 plus 2x. And again, due to the commutative property of addition, technically, kind of, it's the right answer, sort of. But this is really 3 more than twice the value of x. And that's important when we look at something like b. Let's take a look at that one. If n represents a number, then write an expression for 2 less than 1/4 of n. All right, so a couple things, right? I want to just 1/4 of n. You will often see phrases like 2/3 of x, or 1/4 of n, or 1/2 of y, right? When you see a phrase like that, what that implies is that I am multiplying that variable by that fraction, right? 1/4 of n is literally 1/4 times n, because that's what it means to find a fourth of a number, is to multiply it by 1/4, or to divide it by 4. So you could also think about this as n divided by 4. I'm going to think about it right now as 1/4 times n. But I also need to find that number that is 2 less than 1/4 times n, so it's going to be 1/4 times n minus 2. Very critical here that I've got that 1/4 n minus 2 and not 2 minus 1/4 n. That's a completely different phrase. That would be, oh, I'm starting with the number 2, and I'm finding a number that is 1/4 of n less than it. No, I'm starting with 1/4 of the number, and then I'm subtracting 2 to find 2 less than it. All right, let's keep going. Oh, there's a bunch of them here. I'd like you to get a little bit of practice on your own. So let's pause the video now and have you work on C and D on your own, and then we'll come back and do them together. All right, let's take a look at letter C. If S represents Sally's age and her father is 4 years less than 5 times her age, then write an expression for her father's age in terms of S. All right, cool. So, we know that S represents Sally's age and her father is 4 years less, so that's subtraction, than 5 times her age. So imagine I gave you Sally's age and I asked you to calculate her father's age. First thing you'd have to do is find out what 5 times her age was, right? And that's going to be 5 times S. And once you had that, you would then subtract 4 from it. So 5S minus 4. Let's take a look at letter D. If x represents a number, then write an expression for 3 times the sum of x and 10. So this is interesting, right? Again, I want you to always picture how you would do the calculation if I gave you the value of x. So if I said, hey, find out what 3 times the sum of 2 and 10 is, the first thing you would do is you would add 2 and 10 together, you'd get a result, and then you'd multiply that result by 3. In this case, the way that we have to do that is we say, well, I'm going to add x and 10 together, get a result, and I'm going to multiply that result by 3. It is absolutely key that we have the parentheses there. If we don't have the parentheses there, if we write something like this down, 3x plus 10, that is a completely different algebraic expression. 3x plus 10 simply means 10 more than 3 times the number. Right? That's 10 more than 3 times the number. That has nothing to do with adding the number and 10 together, right? We want 3 times the sum of x and 10. So not this guy. All right, let's have you do a few more on your own. Why don't you go ahead and do letter E and letter F. Ooh, letter E is getting way more complicated. Let's take a look. If n represents a number, then write an expression for 7 less than 4 times the difference of n and 5. Ooh, okay, so, again, I give you a number. I say, find a number that's 7 less than 4 times the difference of 11 and 5. So the first thing you'd do is probably find the difference of 11 and 5. Then you'd multiply it by 4 to get 4 times that difference, and then you'd subtract 7 from it. That's exactly what I want to do, except I'm going to do it with the number n. I'm going to take the number n and I'm going to subtract 5. That's the difference of n and 5. Now I want 4 times that difference, so that's that, and now I want 7 less than all of it, right? So there's actually 3 things going on there, not just 2. Let's take a look at letter F. If x represents a number, then write an expression for the ratio of 3 less than x to 2 more than x. All right, ratios can be tricky for people, right? But it's all about fractions, okay? So we know what, 3 less than x is, that's x minus 3. We know what 2 more than x is, that's x plus 2. So let me just, 3 less than x, that's x minus 3. 2 more than x, that's x plus 2. And if I want the ratio of this to this, then what I'm looking for is x minus 3 divided by x plus 2. All right. Let's do a couple more. Man, these like never end. Oh, there they end. Great. Why don't you try letter G and letter H on your own, and then we'll come back and do them again. All right, let's take a look at letter G. If x represents a number, then write an expression for the sum of twice x with twice a number 1 larger than x. Okay, right. Wow. All right, so let's kind of boil this down. Okay, we got a number x, right, and we want a sum. So overall, we're looking at a sum of twice x. Yeah, let's write that down, right? Twice x, that's going to be 2x, with twice a number 1 larger than x. Well, number 1 larger than x is x plus 1, and twice that is going to be 2 times that. So I want the sum of those two things. So that's going to be 2x plus 2 times x plus 1. All right. Yeah. Let's take a look at letter H. If n represents a number, then write an expression for the quotient of twice n with 3 less than n. Again, we'll worry about the quotient in just a moment, right? Twice n, that's simple enough, that's 2n. 3 less than n, that's n minus 3. And quotient means to divide. So we'll have 2n divided by n minus 3. Okay, 2 more. We're getting through these. Pause the video now. Why don't you try I and J, and then we'll revisit them. You know, there's a lot of subparts to a problem when you've got parts I and J. All right, letter I. If y represents a number, then write an expression for 3/4 of the difference of y and 8. All right, got to be careful here, right? If I gave you a number and I said 3/4 of the difference of y and 8, you would want to take that number for y, subtract 8 to find its difference, and then take that result and multiply it by 3/4. 3/4 of means multiply by 3/4, right? 3/4 of means that you're doing 3/4 times something. And what are you multiplying it by? You're multiplying it by the difference of y and 8. So ultimately, we have 3/4 times y minus 8. Okay, let's take a look at the last one, letter J. If x represents a number, then write an expression for the product of twice the number with 5 more than the number. All right, great. Again, there's some easy things here. Twice the number will be 2x. 5 more than the number will be x plus 5. I want an expression for the product of those two, so I'll do 2x times x plus 5. And again, those parentheses are absolutely critical. I want to be thinking of 2x as a single thing, right? Twice the number. And I want to be thinking about x plus 5 as a single thing, 5 more than the number. Okay, let's do a little bit more work with these. One last problem, exercise number 4. Interesting patterns can arise when you play around with numbers. A fairly easy one occurs when you add a number to one less and one more than the number. Do this for a few numbers x and record the results. Then prove a general pattern by writing an expression for the sum of a number with a number 1 less than it and with a number 1 more than it. All right, so this is really cool, right? I'm claiming that if you pick any number, I mean any number, and then you find a number that's 1 more than it and 1 less than it, and you add those 3 together, you'll get some kind of interesting pattern, right? For instance, here, let me fill in one line of this table. Let me pick a random value of x. Let's say we had x equals 7, right? 1 less than that would be 6. 1 more than that would be 8. And if I add those together, 7 plus 6 is 13, plus 8 is 21, right? If I then add these 3 together, I get 21. All right. What I would like you to do now is pause the video and fill in the remaining 3 rows, pick any numbers you want for x, Do one less, one more, add the three numbers up, and see if you can figure out what the pattern seems to be, and then we'll go through an algebraic proof for it. Go ahead and do that now. All right, well, I have no idea what numbers you picked. I'm going to pick some random ones. I'm going to go with 10. One less than it is 9. One more than it is 11. 10 plus 9 is 19. Plus 11 is 30. Let me get a little crazy here. Let me go with 2. One less than it is 1. One more than it is 3. Yeah, that's crazy. 2 plus 1 is 3, plus 3 is equal to 6, right? And finally, I don't know, let me go with 20. One less than it is 19. One more than it is 21. 20 plus 19 is 39, plus 21 is 60. That doesn't look like a 30. That looks like a 3 with a backwards C. That's weird. All right. So it's the pattern, right? I started with 7, I got 21. Started with 10, I got 30. Started with 2, I got 6. Started with 20, and I got 60. Maybe you see it, maybe you don't, right? Let's actually kind of work it out here. What is the general pattern? Well, if the number is x, what I'd like you to do is fill in an expression for 1 more than the number, 1 less than the number, and then fill in an expression for the sum and simplify it. Pause the video now and go ahead and go through that. Well, 1 more than the number. That should be easy given what we've been doing in this lesson, x plus 1. 1 less than the number, also easy, x minus 1. And their sum, let me bring this up so I have a little more space to work, will be x plus 1, whoops, plus x minus 1. That's really the expression for what's going on here. But we can simplify this now, right? Due to the associative property of addition and the commutative property of addition, I can rewrite this by getting rid of the parentheses. Right? I can swing some things around. X plus x, well, that's not x plus x. Ooh. Okay, x plus x plus x plus 1 minus 1. X plus x is 3x. 1 minus 1 is 0, so it's just 3x. So it appears now that I've proven that if I start with any number in this pattern, the result I will get will always be 3 times what I started with. I started with 7, my answer was 21. 21 is 3 times 7. I start with 10, my answer is 30. 3 times 10 is 30. I start with 2, my answer is 6. 3 times 2 is 6. 20, I get 60, right? And there's the proof. It would work with any number I started with. And I can only see that really through these algebraic manipulations. We're going to get a lot more practice on that in the last lesson in this unit. Let's do a little summary. All right. You know, we will be doing a ton of work, and it's not lesson 1. I think this is lesson 11. We're going to be doing a ton of work when we have to do some translation of English phrases into mathematical expressions. There's a lot of keywords like greater and less and product and quotient, sum, difference, all of that you need to get a lot of practice on this lesson's homework in order to become fluent with that. It's really, really critical because there's going to be, unfortunately, a lot of word problems in algebra. All right, for now I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.